when you're not allowed to directly plug in or directly substitute your x value into the expression when calculating a limit, you have to use some sort of other technique to get to a position where you can do that. So the first one, and the most widely and commonly used one, is called factor and cancel. I call it that. And it basically consists on doing exactly that, factoring and then canceling. So number 1 here, or item A here, does not allow us to directly plug in 4, because if you did, right, and let me maybe put a little bubble there, so you would think the bottom would be, let's just write the whole thing, it would be 4 squared minus 6 times 4 plus 8 divided by 4 squared minus 16, and okay, this is something divided by 0. You're not allowed to do that, so you're not allowed to directly substitute right now. So what do? Exactly what I said. You factor and cancel. So that would be the limit. X goes to 0. If you look, x goes to 4. If you look at the top, you can factor that as, so we're looking for two numbers that add up to 6, multiply up to 8, so x minus 2, x minus 4. And the bottom is the difference of squares, so x minus 4, x plus 4, right? A squared minus b squared, right, is a plus b times a minus b. The fact that you've done that now allows you to cancel these two terms out. Remember, when you're calculating a limit when x approaches 4, x never equals to 4. It's just very, very close to 4, but never equal to 4. So that means x minus 4 is not 0, and you can divide by 0. So you are allowed to cancel these out. And then the limit, as x approaches 4, of x minus 2, that's what's left, x plus 4. Now, if you plug in 4, there is no issue, right? You don't have a 0 on the denominator now. So that would just be, and I'll do that here, 4 minus 2, 4 plus 4, that's 2 over 8, that's 1/4. Direct substitution now works, and you're allowed to do that. Again, notice that on this jump, I stopped writing the limit because I've already plugged in x. There's no longer any x, so there isn't any more need for the limit symbol. So that's factor and cancel. The other technique that I wanted to show on this video is using conjugates. If you look at item B, there is no obvious factoring that I could do. So how would I figure that out, right? Note that if instead of a square root and a regular x, you'd had a x and then x squared, that could work. So that's one way to get around this, but the way that I want to show you today is using conjugates. Remember when you were working with complex numbers, so maybe I'll put a little bubble there. So when you're dealing with complex numbers and you had, say, a 2 plus I at the bottom, you would multiply by the conjugate being 2 minus I over 2 minus I. Or when you were rationalizing denominators, you did the same. So we're going to do that here as well to get rid of that square root on the top. So we're going to multiply that by, so that's the limit, as x approaches 9, of root x minus 3, x minus 9. I'll multiply it by root x plus 3, root x plus 3. I got to multiply by the same thing over top and at the bottom so that I don't change the value of the fraction. And then that will be equal to, okay, that's the same as the difference of squares we had before. So a minus b times a plus b, that's a squared. So x squared. So, sorry, not x squared. So a squared is square root of x squared, right? So this is my a, this is my b. So a squared minus b squared. That's the top, and the bottom is just x minus 9 times root x plus 3. So if I rewrite the top, I will get x minus 9 over x minus 9 root x plus 3. So that's exactly what I wanted. I'm allowed to cancel these. So that's the limit x approaches 9 over 1 over root x plus 3. There's no issue with zeros on the denominator. Now this is a plus symbol, not a minus symbol, so I have no issue. 1 over root 9 plus 3, that's 1 over 6. 3 plus 3 at the bottom there. So that's my limit. A couple of observations before. Same thing, right? X is approaching 9, so it never equals to 9. So that means x minus 9 never equals to 0, and I'm allowed to cancel these two. Another observation. Square root of x squared could be x or minus x, depending on whether x is positive or negative, right? If x were negative, then the answer would have to be positive. So it'd have to be minus x, right? When x is negative, minus x is positive. But the fact that we have this sort of implicitly tells us that x is supposed to be positive, or we would not be able to calculate this. So the answer is x in here. This is just a subtle thing to keep in mind. We may talk about this in more detail in other videos. Let's do this last example to see what we get from it. So if we try and calculate, let's say first, the limit as x approaches 2 from the left of x cubed minus 5x squared plus 6x over root x minus 2, I would have, first of all, I can cancel, or excuse me, the factor of the top, pull out an x to get x squared minus 5x plus 6, and that's a regular quadratic function, and I can rewrite the bottom. Instead of writing the square root, I can write x minus 2 to the 1/2 power. And then I can further factor the top into x. So the top, the second factor of the top is a quadratic function, and the two roots, the two numbers that I'm looking for, they add up to 5, and they multiply to 6, so x minus 2, x minus 3, right? So minus 2 plus minus 3, that's minus 5, so we're good. And multiplied, they give 6. So we're okay on the top. And then x minus 2, 1/2 is what I have. I could have noticed before, but since I'll have some work to do on the other end, I just thought I'd do it here. But I can't go much further than this, because this thing is already not well defined. And I'll note that. Realize that x approaching 2 from the left means x is less than 2, and therefore x minus 2 is less than 0, so the root of this is undefined. So this limit does not exist, and I'll write it here. Not only did I say that it does not exist, but I explained why. Okay, so the limit from the left does not exist. Now the limit from the right, then I'll save some of the work I did on the other end. I do the exact same calculations to end up with the limit of x minus 2, x times x minus 2, x minus 3, and x minus 2 to the 1/2. Now this is well defined because x is bigger than 2, which means x minus 2 is bigger than 0, and therefore the limit, the square root of it, is well defined. And now I can cancel these two, not cancel, but divide them, right? So this is x minus 2 to the first power, x minus 2 to the 1/2 power. That allows me to do a subtraction of the powers. So I'm taking 1 minus 1/2 equals 1/2. So I get that. And that's finally, I want to put my equal signs there. That finally equals 2. So I am now able to plug in the whole thing, so I don't have to write another limit. So that's just plugging in the 2. And that's 2 times 2 minus 2, square root of 2 minus 2. And 2 minus 3. So that's 2 times 0 times minus 1. So that's just 0. That is my limit. I was able to calculate it. So the limit from the left-hand side, the limit from the left does not exist. The limit from the right equals 0. So that is enough to say that the limit without choosing a side, so the choose-sided limit, does not exist. And that's because, maybe I'll write that better, whenever a two-sided limit exists, for it to exist, we need both one-sided limits to exist. That's kind of obvious, right? For the two-sided limit to exist, each one-sided limit needs to exist. And they also have to be equal, but in this case, I don't even need to check that because one of them already does not exist.